Okay, guys, this is a huge PowerPoint. Over 80 slides. I know, terrible. But I am going to just talk about Unit 1 for today, and then I will continue on as we move forward. So, Unit 1 is it was 7 to 9%. I just scaled that up, eliminating the last 2 units. So now it should be approximately 12% of your exam if they just scale it straight forward. So we have 8 sections, and I'm going to go through each one of these one by one. Moles and molar mass. This is something we learned in honors chemistry. You should be able to use Avogadro's number. Given grams, you should be able to calculate moles or particles. I would strongly urge you to use dimensional analysis. Make sure you use your units and substances. That way you won't make a careless error. I will post this huge PowerPoint as a PDF later so you can review it to your heart's content. Mass spectroscopy. Mass spec is pretty straightforward. They will only give you mass spec for elements. And I've shown you a picture here on the right that has the spectrum for boron. Boron has 2 isotopes that are naturally occurring. You can get the relative abundance from the scale off to the left of that. And you would convert that to a decimal because this is a percent. Multiply it by the mass, so it would be 10 AMUs times whatever that percent plus, etc. So you should be able to take this data and tell me how many isotopes are there. You should be able to take this data and tell me what the average molar mass is for boron. If you don't know it's boron, you should be able to take this data, calculate how many isotopes there are, calculate the average atomic mass, and then identify it. We've done this a lot. I think this should be pretty straightforward. If you have questions on anything, please make sure you put it on the list for me to go over in more depth. Again, this is just expected to be kind of an overview. So, elemental composition of pure substances. It would be something like the problem I put here on the right. A compound has this many percentages of these different elements. The first thing I would do on this type of problem is take those percents and make them 100 grams. So it would be 24.7 grams of calcium, 1.2 grams of hydrogen, etc. Then divide each by the molar mass of that element will give you the moles of each element in this compound. Once you have the moles of each, then you're going to divide all the moles by the smallest one. And so that should give you a pretty simple analysis. If you need some more help with this, let me know. We had one like this on the worksheet or the questions for the review that were last week. So you should have an example of this to go by. Composition of mixtures. So this one gets a little more into they can ask some lab type questions here. If they had like 3 different substances, they could do a couple of reactions to figure out the mass of substance A versus substance B, and then the remainder would be substance C. I plan on working 1 or 2 of these for you later. You should also be able to do things like what is the percent of compound A? You would take what you get for that mass, divide by the total mass, times 100, just like any other percent. Atomic structure and electron configuration. I think this is pretty straightforward. You do know how to do electron configurations. The assignment of quantum numbers to electron subshells of an atom will not be assessed on the AP exam. So you've got easier things to deal with. However, it will require more thinking. Things like applying Coulomb's law. And you have to just say, because of Coulomb's law X, no. You have to say, if we're comparing, let's say, lithium and calcium, or lithium and potassium, they're both in the same column, so they have the same outer electron configuration, but in potassium, the electrons are further from the nucleus, and therefore according to Coulomb's law, the attractive force for that valence electron would be lower than it would be for lithium. So I've used Coulomb's law to explain why the ionization energy for potassium is lower than the ionization energy for lithium. So you should be able to use different subshells, Coulomb's law, effective nuclear charge. Photon electron spectroscopy. This is pretty straightforward. I did not put in a problem here because we have done a number of these problems. You also have something on plus portals that goes over this, and you should be able to tell me the electron configuration and what subshell or what shell they're in, things like that. We're almost finished with this one. Periodic trends. Periodic trends is not something where I want you to just say this is more electronegative than that. You have to tell me why. And this is one of those justify your answer things. And the 4 areas that they typically look at are listed there: ionization energy, atomic and ionic radii, electron affinity, and electronegativity. So you will have to predict, or they will give you a trend and you have to explain why. So again, periodic trends come back to Coulomb's law and electron configuration. So you may have to write electron configurations, but they're the exceptions to the off-ball principle will not be tested on the AP exam, as you can see there. Valence electrons and ionic compounds. You should understand that ionic compounds are formed by the transfer of electrons. These have to be a metal and a nonmetal. This would not be between 2 metals or 2 nonmetals. When we have 2 nonmetals, that will be a covalent or molecular compound, not an ionic compound. So you should be able to explain trends in reactivity. Why is fluorine more electronegative than chlorine when forming bonds with X, Y, or Z? This has to be related to their location on the periodic table, but that would not be an answer. You would have to say, since fluorine is higher on the periodic table, the electrons are closer to the nucleus. Not that it's the most electronegative element on the periodic table, but the electrons, talk about electrons, are closer to the nuclei, therefore they are more tightly held, things like that. So I will come back and start on Unit 2 in the next video. Thank you.